you've ever sat in an airplane waiting for takeoff and wondered why is this taking forever, congratulations, you've just entered the world of management science. Like the last couple of videos, this one's about how we can use math and logic to make real-world systems more efficient, from scheduling deliveries and assigning workers to, in this case, turning planes around faster. One of the key tools for doing that is something called critical path analysis. It's basically a way to figure out which tasks in a project are actually controlling how long the whole thing takes. Let's take an airplane that just landed. Before it can take off again, a few things need to happen. Passengers get off, which takes 13 minutes, luggage is unloaded, which takes 25 minutes, the cabin gets cleaned, which is 15 minutes, new luggage is loaded, which is 22 minutes, and finally, new passengers board in 27 minutes. To visualize this, we'll label the tasks and map them out as a digraph, basically a flowchart showing what depends on what. Some tasks can happen at the same time, like unloading passengers and cargo, but you can't clean until passengers are off, you can't load new luggage until old is out, and airline rules say that new passengers can't board until the cabin's clean and the old cargo's gone. Our analysis starts by finding the critical path, or the longest chain of dependent tasks. There are only 3 paths from start to finish in this graph, so we can easily find the longest, which is ACE, a total time of 55 minutes. That means even if everything else runs perfectly in parallel, the absolute fastest turnaround time is 55 minutes. Now let's say that the airline tries to speed things up by installing a second jetway, so unloading and boarding passengers happens twice as fast. That sounds like it'd save almost 20 minutes, right? But cutting passenger time in half shifts the critical path. The new longest chain is BD, which still takes 47 minutes total. So even after spending all that money on another jetway, the overall time only drops by 8 minutes, not exactly the massive improvement they hoped for, unless they also find a way to speed up the luggage handling. Understanding the critical path of a project can literally save the company thousands of dollars. By spotting the bottlenecks, even if they're hidden under other layers, companies can decide where improvements would actually pay off and allocate their budgets where they'll make the biggest impact. This kind of reasoning is super useful in project management. Using slightly different methods of creating a digraph can even tell you the earliest and latest that each task can start or finish without delaying the whole thing. Here's a great YouTube video that goes deeper into this, showing how to calculate those earliest and latest times for every single step. If you've watched to this point in my video, you're obviously interested in this, so give this YouTube video a watch. What we just went over was a simple example, but imagine scaling that up to a construction company coordinating hundreds of tasks, or a hospital scheduling staff and specialized equipment around the clock. Of course, math doesn't exist in a vacuum. Real life throws curveballs, a spilled drink that delays cleaning, or an emergency surgery that shuffles around the entire schedule at a hospital. That's where understanding the critical path really matters. It gives you a framework to build an efficient system and adapt when things don't go according to plan. Next time, we'll talk about heuristic algorithms, ways to find good, practical solutions to problems like these when perfection isn't realistic. Stick around, and thanks for watching.